All right, let's take a look at min stack. All right, min stack. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Retrieving the minimum element. Okay. So, all right. So min stack, okay. Push pushes the element value into stack. Pop removes the element on top of the stack. Top gets the top element of the stack. Minimum? Or is it just reading the value of the minimum? Oh, okay. I see it here. Yeah. So push -2, push 0, push -3. Get min. Min is -3. We pop. And since -3 was the last thing that was popped, we pop that and top. So, okay. So get min does not pop. Okay. All right. So that actually, then we could actually have a separate. Yeah. We could just do it separate, right? Copy. And what's the number on this one? 155. Right here. 0155 min stack. Paste. Oh, right. And then we have to get rid of these doc comments. Otherwise, the compiler is going to complain. All right. Self means to take it. Okay. Yeah. I know how to do that. So push is mutable, pop is mutable, but top and get min are both immutable. All right. So just to get this to build, let's just say self here. Push does nothing. Oops. Pop. Oh, pop has to return. Why do they have that? Oh, pop doesn't return anything. Pop just pops the value and then leaves it alone. Okay. Top returns an I32 and then get min returns an I32. Okay. So this should build. All right, and now we can write our test cases. Oh, test mod. Test, oh, EX1. And we only have one. Leetcode, sorry, I don't know how to pronounce your name. You have to let me know how to pronounce that. Welcome to the chat. Leetcode says, maybe you can use a stack of mins. Yeah, so I was kind of thinking that in the back of my head, we could do, have a vector, which is the stack, and then just have a min stack, right? And whenever we push something, what we can do is push it to the stack, and then if it's less than the top of the min stack, then push it to the min stack. And then get min, all get min needs to do is return the top of the min stack. And then when we pop, we have to look, are we popping off the same value that went on the min stack? Right? And then pop, if that's true, then just pop both of them. And if it's not true, then just pop the stack. Right? I think it's straightforward. It's just making sure we handle all the corner cases. So let's see, this is the example code. So let's write this as our test. Let mut min stack equals min stack new, like this. Min stack push -2, min stack push 0. Let me just copy paste. See, And now I just have to rename all the variables. Like this. And then we have to add asserts. Assert EQ -3. Right? And this should return EQ 0. And this should return -2. Like that, right? And this test should fail. Oh, right. Doesn't even build yet. Let's build. Let's make it easy on ourselves. Okay. Oh, right. And that's the other thing, is this needs to be pub. And all these need to be pub, because if they're not, then the library complains that the functions aren't used. Oops. Did I forget? I forgot one right here. Okay. And then get min, right? Those need to be fixed. Okay, and then we have, we have test failures. Okay, so let's see if it's that simple, right? A push pushes onto our stack, self stack push val. And then we can say if I want to push on min stack if the top of the min stack is less than, or is greater than, is greater than the value that we're pushing. So we can say if self min stack, we have to check to see if it is empty, or self min stack last unwrap is greater than or equal to val self min stack push val. If the I'm just trying to think if there's any corner cases or gotchas. What's the error here? Why is that underlined? Oh. Okay. That might be all we need to do. Pop is obvious. Well, pop is obvious. Pop is, we can say if let sum val is equal to self stack pop. Right, then this should be an I32, and we can then say if self min stack, if it's not empty, and self min stack last unwrap is equal to the val, then we can pop that self min stack pop. Right, top then just becomes the top of the one stack, right? So self stack last. What happens? Are we guaranteed? Methods pop, top, and get min operations will always be called on non-empty stacks. Okay. So we can actually get rid of one layer here, right? Oops. Like this. Unwrap. That saves us a little bit, right? Because we're always guaranteed that this unwrap will always unwrap. So that means this will always unwrap. And this is self min stack last unwrap. And that fails because I forgot the word let. And it doesn't like this. Expected I32. Oh, I have to deref it. Okay. The tests all pass. Should we throw this at Leetcode and see what Leetcode thinks? Submit. Look at that. Okay, beats 14.29% in terms of memory and beats 92.86% in terms of runtime. I don't know, how slow can you get with this? Let's see what this one does. Ooh, this one just uses a single stack. Oh. This doesn't look right. Oh, I see. And that's why it's slow. That's why it's slow. They're not using the last operator either. But anyway, that's certainly one way to do it. Get the minimum value. Well, just look for the minimum value. But that's why it ends up being the slowest one. Okay. X out of that. Very good. All right, so that's minstack. Let's check with Clippy. Very good. Git status, git add source, git commit -m problem 155 minstack. All right, I probably have time for one more. Ooh, this might be tough.